Alright, Tree and Pre-Calc fam. We're going to go over a couple of examples quick because I know some of us are stressing about this for the test. I don't think y'all should. I know that y'all are smart. I know that y'all know what you're doing. I think that our biggest struggle with this is that sometimes we're not comfortable with not being told what to do, not having a process to follow. But this is something where y'all are going to have to think for yourselves. But y'all can do that, and I know that y'all know how to do math, and y'all know how to do algebra right, so we'll be fine with this. So I've got an example here, and we're going to think about the three things that we can do. We can switch equations, we can multiply an equation by a constant, or we can add a row to another row, right? So we'll get going with this one, and the first thing that I see with this, if you want a process to follow, if you want a first step every time, something good to do is to bring any equation that has no coefficient with x, just a coefficient of 1, bring that one to the top. That one's going to be the easiest to scale, so you're going to want that one to be at the top so that you don't remove any of those variables. It's really easy to scale an equation whose x coefficient is 1, because then you can easily make it match up with the 2 and the 3 and eliminate those variables. So that's something that we can do, and that's something that I'm going to do real quick. So my first step is going to be to switch the bottom two equations, and just because I don't have that much space, I'm just going to do that right here in a different colored marker. So stick with me while I do that, and if you want, feel free to write this down, try it out yourself, and check out the solution when you feel like you're comfortable with it. And forgive me if my cat messes up the video. She's going crazy right now. But anyway, we'll get moving here. So like I said, the first thing I'm going to do is switch these two equations. So I got to find my eraser. Okay, so my green marker doesn't work at all. The perks of being at home doing this, so I'm going to rewrite it in black still. Hopefully I got the black marker that works. And we're going to go from there. So try to follow along, try to see what I'm doing, listen to me step by step as I go through this, because I'm only going to have one marker. I promise I'll put that on the grocery list for next time. So we're going to switch these equations. Okay, so after we switch those two first, I'm going to multiply the top equation by 3 so that we can eliminate one of the variables from one. We can eliminate the x variable from the middle equation. So I'm going to multiply all this by 3. And that's going to bring me down here. I'm going to end up with this, and then, like always, we only do operations to 1 at a time, just so that we keep everything straight, so we're just going to rewrite the other two equations just as they are. And here's my kitty. Okay, so now that we have this equation, something that I had just mentioned was that we can eliminate this variable. So if we want to do that, I suppose we can multiply this top one by -1, which is what I'm going to do, and I'm just going to flip the signs of all the terms so that we can add these two together to get rid of that 3x there. So So as you can see, I just flipped all of these signs. Flipped all these signs so that now we can add row 1. And what do we get when we add row 1 to this row? We get nothing here, and we get 3y and negative 10z. And that equals negative 13. Sorry, I just had to make sure that was right. But yeah, so now that we have this, do we do anything to the other two? No, we do not. So we're going to rewrite these. And what I'm actually going to do is on my way down here, so as I rewrite this equation, I'm going to multiply by 1/3, just so that we can bring this equation back to this normal one, so that we can rescale this x. So watch as I divide this equation by 3 and this one. And I'm only doing this because I don't have a whole lot of room on this whiteboard. I would highly suggest you rewriting the entire system, as much work as it is, just to keep your work straight. So I'm going to do this and get now I'm just going to write the bottom one. And then as we can see here, we can do a similar process to eliminate this x value. So we're going to multiply this top one by 2. And that'll give us negative 2x plus 4y minus 6z equals negative 12. And so if we add row 1 to that one, our new system is going to look like and what I'm going to do again is rewrite this one after we rescale it. So I'll draw that again. Times 1/2 as we rewrite it right here. So we're back to the original negative equation here. This one has stayed the same. The middle row has stayed the same. And the bottom row, after adding row 1 to it, got nothing here. We've got 5y, and then we've got negative 7z. Right? Or negative 8z, sorry. Equals negative 13. So once we're here, something that I recognize is that since these both equal the same number, that means that these two things are also equal. So a step you can do instead of continuing to do elimination is set these two things equal to each other. So we'll do that up here. And so this is like saying, like, if this is negative 13 on this side, since we have an equal sign, we know that this is going to equal negative 13 as well. Since this equals negative 13, or no, sorry, and same thing with this bottom one. Since this is negative 13, there's an equal sign, this equals negative 13 as well. And if these both equal the same thing, then we can very easily and mathematically correctly set these two equations equal to each other. And so that's what I'm doing up here. And since we have only two variables, we can solve for one of them and then substitute the rest back in. So we're almost there. So let's add 8z to both sides. And then we're going to subtract 3y from both sides. And we're going to get negative 2z equals 2y. And we can divide by 2 on both sides to isolate the y. And we get y equals negative z. And that doesn't give us a value yet, but we know that we can plug this back into the original equations to get our other values. So if we plug this, or we can plug it back into anything. So let's plug it back into something simple like this down here. So if we know that y equals negative z, this equation becomes 5 by negative z minus 8z equals negative 13. Forgive me there, that's negative 13. And so we know that negative 5z and negative 8z equal what? Negative 13z. And that's equal to negative 13. So we know that z equals 1. And if we plug that back into everything, we see that y will equal negative 1 because 8 times 1 is 8. And if we add that to both sides, we end up with negative 5 and 5y. So y equals negative 1 there. And then when we plug both of these back into here, we can see that blank minus, or x plus 2 plus 3 equals 6. And so 6 minus 5, x equals 1. And so our final solution is going to be the ordered triple 1, negative 1, 1. I'm sorry this got messy. I just wanted to give you all an example over the weekend. I'll give you all another one tomorrow, and then we'll go over some linear programming as well. But I just wanted to give a video, so just in case anybody wanted to study tonight or tomorrow. So I'll see you soon. If not Monday, then Tuesday. And we'll go over this a little more, and hopefully I'll be ready for the test. So peace out. Good luck. I hope studying is going well, and I'll see you soon.